Today we're going to look at Chapter 7, Topic 7, which is how to use the common log to evaluate logarithms and how to use that to help you solve logarithms as well. So let's first look at how you evaluate a common log, which is a base 10 in the calculator. Typically, your calculator will have a log button, and that is a log base 10 button. So if I want to evaluate log base 10 of 5, I just hit 5 log, take a log of it, and I get this number. Now I want to round it, it says to the 10,000ths place, so that's 4 decimals, so 0.6989, because it goes 10, tenths, hundredths, thousandths, 10,000ths, so 0.6989. If I want to do log of 0.3, I'll just do the same thing, 0.3, and I'll take a logarithm of it, and this is what I get. I'll round it off, so negative 0.5228. So that's how you evaluate a logarithm in the calculator. Now we can use something called the change of base formula to evaluate any logarithm, even if the base is not 10. All right, it's a simple change in formula or change of base to evaluate. So say we have log base b of x, then we would take the natural log of x and divide that by the not the natural log, the common log. We take the common log of x and divide that by the common log of the base. Okay, so for instance, I want to take log base 3 of 20, so this isn't the common log, I can't do this in the calculator. I can use this change of base formula. So I can do log of 20, so log of the number over log of the base. And I can calculate this instead, and this will give me a value. So I will do log of 20 divided by log of 3, and don't forget to hit equals, because it's not going to give you the answer unless you hit equals. So it's log 20 divided by log 3, which is 2.7268. Okay, that's what we evaluate to. So that's the value of log base 3 of 20. So it's 3, so if you raise 3 to that power, you will get 20. And let's just check to make sure that's true, 7268. So 3 raised to the 2.7268 power. It's 19.999 and should be 20. It's only like that because I rounded. All right, let's look at log base 8 of 6. Okay, so this is common log of 6 over common log of the base, which is 8. So I'll put this in the calculator. So log of 6 divided by log of 8 equals, and this is what I get. Whoops. So it's 0.8616. That's the value of log base 8 of 6. Now we're going to use this to solve some exponential equations that could not otherwise be solved. And there's two ways to do this. Right? We'll isolate the base on one side of the equation. We'll take the common log of both sides of the equation. We'll bring the exponent to the front by using the power property, which is what we learned before, and then we'll solve, and don't forget to round to the 10,000ths place. Okay, so we'll see these examples on the next page. So first one, 4 to the x equals 19. This is an exponential equation, and typically we would try to solve this by making the bases the same, but that's not possible here. I can't write 19 with a base of 4 or anything else besides 19. So I'm going to solve this using this method, and I'm going to take the common log of both sides. So I'm going to take the common log of the left side and the common log of the right side. Now the power property says that if I have an exponent for a logarithm inside a logarithm, then I can bring it to the outside. So I can make this x times log of 4 equals log of 19. And now I can solve for x by dividing both sides by log of 4. So x is equal to log 19 over log of 4, which I can calculate using a calculator. 19 divided by log of 4 equals, and I'll round it to the thousands place, 2.1239. So that would be the solution to the equation 4 to the x equals 19. If you plug in this number for x, you get 19. Let's look at number 2. 5 to the x minus 4 plus 3 equals 19. Okay, so the first thing I'm going to want to do is I'm going to want to get that base with the exponent by itself. So let me move the 3 to the other side. So 5 to the x minus 4 equals 16. And now I will take the log of both sides, the common log of both sides. Log of 5 to the x minus 4 equals log of 16. Power property says that I can bring the exponent to the outside. So x minus 4 times log of 5 equals log of 16. And then I can get that x minus 4 by itself by dividing log of 5 on both sides. So far, I have x minus 4, that cancels, equals log 16 over log of 5. Now I'm still trying to solve for x, so I do want to get rid of this 4. So x is equal to log 16 over log 5 plus 4. And I would use a calculator to calculate this. So log 16 over log 5 plus 4. So log 16 over log 5 is this. Add 4 to that, and I get this. So 5.7227. And that would be my solution to this problem up here. All right, that's my solution to my equation for number 2. All right, and now number 3, 8 to the 3x equals 15. First step is to get the base by itself, which it is. The next step is to take the common log of both sides. So 8 to the 3x equals common log of 15. Power property says that I can take this exponent to the outside. So this is 3x times log of 8 equals log of 15. And now I can start solving this for x. It's multiplied by log of 8, so I'll divide by log of 8. So 3x equals log of 15 over log of 8. And then I'm going to divide that by 3. Okay, so I'm going to put this in the calculator. I'm going to do log 15 over log of 8, and then whatever I get from that, I'll divide it by 3. All right, so log 15, log of 8, and then I'll divide that by 3, which gives me this, 0.4340, or 0.434. All right, so this is my solution. And we should be able to check that and make sure that it works. I'll just quickly check it in a calculator. To the 1 point, oops. And it does. Now, if it's easier for you, you can calculate log base 15 over log 8, or sorry, log 15 over log 8, and then divide by 3, okay? But it looks kind of weird when I leave it like this, I know that. Now, there is another way that you can do this. There is a second option that you have for solving these types of equations. Okay, you can isolate the base on one side of the equation, and then you can simply rewrite it in log form and then solve for x. Okay, because we know how to write things in log form. We just have to use our triangle. So for example, number 4, 3 to the x plus 4 equals 19. If I use my triangle, I can write this in log form because this is 3 to the x plus 4 equals 19. So if I rewrite this in log form, I have log base 3 of 19 equals x plus 4. And then I can subtract 4. So log base 3 of 19 minus 4 equals x. And then to calculate this, I would simply use the change of base formula. This would become log 19 over log 3 minus 4 equals x. And then I can calculate this using the calculator. Okay, so you end up getting the same thing regardless of how you do it. So let's take a look at this, what I would get here. So x is equal to log 19 over log 3 minus 4. So log 19 over log 3 is this, and then minus 4 would be this, negative 1.3198. So negative 1.3198. And that is my solution to number 4. I did it a slightly different way, but it still works. You get essentially the same thing if you had done it the other way. Now, this is just another way to do it. And then number 5, 6 to the 2x plus 1 minus 1 equals 18. All right, before you can use this method, you do need to make sure that the exponent term is by itself, so I do need to put this 1 on the other side. So I get 6 to the 2x plus 1 equals 19. And then if I rewrite this in log form, then this would be, so 6, 2x plus 1, 19. I rewrite this in log form, that will give me log base 6 of 19 equals 2x plus 1. and then I can solve this for x. So I got log, well, let me first write this. Before I start solving this for x, let me first write the left side using a change of base. So I'll say that's log 19 over log 6. And now I can start doing this. It's just going to make it easier so I don't have to worry about it later. So I got log of 19 over log of 6, and you can calculate this as you go. It's just better to do it all at once in the calculator. All right, and then I'll divide both sides by 2. Okay, so this whole thing gets divided by 2. So I end up with x is equal to log 19 over log 6 minus 1, and this whole thing's divided by 2. Okay, so now I'll calculate this, and you got to make sure that you put it in the calculator correctly. You got to use PEMDAS. So I'll do this first, then subtract 1, and then divide by 2. Okay, so I'm going to do log 19 over log 6, which is this, and then I'll subtract 1 minus 1 equals, and then I'll divide by 2 equals, so we get 0.3216 or 17, 0.3217. Okay, so that is our solution. I'll put that over here, 0.3217. And we can put this in and check if we so feel the need to. And you probably should check this when you get the chance, okay? You just plug it in here, multiply it by 2, add 1. Let me just do that on the calculator. So we have 0.3217, so 0.3217 times 2 plus 1. Okay, so 1.6434 is the exponent here. So I'll raise 6 to the power of that, 1.6434. So 6 to the 1.6434 equals 19. And then I'll subtract 1, which is equal to 18. Okay, 18.00. All right, so it turns out that when you plug in this number, the equation is true, so that makes it our solution. All right, here are the homework problems.